Hi, welcome to 3.1 homework help. Number 1 is on the board. It says the sequences below exemplify either an additive, which is arithmetic, or a multiplicative, which is geometric pattern. Identify the type of sequence, fill in the missing values on the table, and write an equation. Okay, so this is a throwback to IM1, all right? So the first thing you have to do is identify whether it's arithmetic or geometric, all right? Just for your memory. Oh, here it is. Arithmetic sequences, we are adding. You need to zoom in just a little bit. Over this way. There. Adding the same number each time. Okay, you're adding the same number each time. So arithmetic is linear. All right? Ooh. Linear. Okay. On the other hand, geometric you are multiplying. So today we are dealing with geometric sequences. You're multiplying by the, move out of the way a second, by the same number. All right, so you're multiplying by the same number each time. So geometric is exponential, all right, which is what we are working with today. Okay. Multiplying by the same number each time. So geometric is the same as exponential. All right. So with that in mind, let's look at number 1. We have to figure out, is it arithmetic or is it geometric? What are they doing to get from one number to the next? So from 2 to 4, well, I'm adding 2. 4 to 8, 4, if I add 2 again, that doesn't work. 4 plus 2 is 6, not 8. Oh. I think I just got a marker on myself. Oh well. Okay, so it's not that. So then, well, you're also, what's another way we can get from 4 to 8? Sorry, from 2 to 4. You're multiplying by 2, okay? So you're multiplying by 2 every time, times 2, times 2, times 2, times 2. Oops, that was a bad 2. So then you have to fill in your table. So you just can continue that. 32 times 2 is 64. 64 times 2 is 128. Okay, and then 128 times 2 is 256. Okay, so that's your table. And then we also have to, type of sequence. We didn't write it down. It is geometric. So it's a geometric sequence because we're multiplying by the same number each time. Okay? So that's your sequence. It's geometric. And then we have to write an equation, I think. Yeah. Okay, so to write an equation for a geometric, you're using this form. Y equals AB to the x. Okay? You could write it using your first term, but I want you to write it using the y-intercept. So look at our table. They don't give us the y-intercept. The y-intercept, that's the 0th term. Okay, so how can we find out the y-intercept? What would it be? You can think about it in terms of what would fit our pattern here. Okay, so we're multiplying by 2 each time. So what you do is you can do, if they give you the first term, you can just do your pattern backwards. So 2 divided by 2 is just 1. And that would fit our pattern. 1 times 2 is 2. Okay, so your y-intercept is 1. So that would be y equals 1. And then b is what you're multiplying by every time, which is 2. And then to the x power. All right. You don't have to write that. You can leave the 1 if you want, but if I multiply 2 to the x by 1, I'm just going to get 2 to the x. Okay, so that would be your answer. Okay, so that's number 1. Lay pause. Lay resume. Okay, this is number 5. So you're still trying to figure out the type of sequence. The type of sequence and the equation. So go ahead and take a look at the table. Oh, is it going to be arithmetic or geometric? Ow. Okay, well, to get from -9 to -2, we'd be multiplying by something, some decimal. So I don't want to deal with that. Okay, let's try adding. So -9 to 2, I'm adding 7. -2 to 5, is that adding 7? Yes. Okay, and then from 5 to 12, that's also plus 7. All right, so you're adding 7 each time. Yes, yes. So we're adding the same amount each time. Is that geometric or arithmetic? Arithmetic. Arithmetic and adding both start with an A. Arithmetic is adding. Arithmetic. So this is arithmetic. Arithmetic. Okay? Sequence is arithmetic. It's an arithmetic sequence, which means it's also linear. Actually, yes, which means it's also linear. So when you go to write the equation, you could either write it in point slope, or the most common linear equation is going to be this. Y equals mx plus b, right? Where m is your slope, and b is your y-intercept. Okay? Couple different ways you could figure, well, okay, the slope is change in y over the change in x, right? So our change in y is 7. Our change in x, they're just going up by 1. So it's just 7 over 1. So y equals 7x, that's your slope. And then what's your y-intercept? Do not write -9. That's not your y-intercept, okay? That's your first term. This is when x is 1. So what's your 0th term? That's what you need to find out. I'm waiting for you to figure it out. Okay, so once again, I would just do my pattern backwards. Or what number plus 7 is -9? Okay, so you can take -9 and subtract 7, and that will give you -16. Okay, so that would be your equation there. Oh, I'll rewrite it over here. Y equals 7x. Whoa. That got away from me. Y equals 7x minus 16. All right, that's your equation. Let me see if they want you to write it the other way. Nope. Okay, we're gonna do it that way. So that is number 5. Okay. I actually want to look at, what number is this? Well, numbers 6 through 11. I don't want to do the exact problem, so I'm just gonna, that's where you have a graph and you have to analyze the graph. So I'm just gonna make my own graph real quick. Hold on. I guess I could have done this with you paused, but I didn't. Or with me pause, whatever. Okay, let's just do, all right, so this will be 1, 2, 3, 4, 5, 6, and so on and so forth. So on and so forth. Actually, I'm going to pause you. Hold on. Okay, don't read too much into my graph, okay? It's not going to be super accurate. Okay. I just want to show you how to do the problems 6 through 11, give you the idea. So on 6 and 8, all right. So if I'm asked to find f of, let's say f of 1, and it wants me to figure out what that is. That means I'm going to substitute, or sorry, I don't have an equation. That means I'm going to look at when x is equal to 1, what is y? Actually, I'm going to do that point. Okay. Instead of f of 1, we're going to do f of 3. Okay? So when x equals 3, y is 4. When x equals 3, so if it's inside the parentheses, like, okay. See how it replaces the x? Yes. So that means that x is equal to 3. What's y? 4. All right, so you're just looking at the graph. Another one, f of, I don't know what other point is like decent on my graph. F of 5 equals, so f is 5, so x is 5, what is y? You're just looking at the graph, and is 8. All right, so that's that kind, and then they're going to give you f of x is equal to 6. Okay, f of x is equal to 6. Right, once again, these are not your actual homework problems. I'm just doing an example based on it. Okay, f of x equals 6. So look at my graph that I made, but this time they're telling you that f of x is equal to 6, which means the function is equal to 6, which means y is equal to 6. Y is equal to 6, so now you're trying to find x. You're trying to find x. So y is 6, right? X is 4. Right there. So y is 6, so x is 4. Oh, I think, what does it say? Does it say find x? No. Yes, it says find where f of x equals 6. So that is when x is equal to 4. Okay, so you're just analyzing your graph. All right. Okay. I did, if you're in period 5, I already did number 12 with you. Sorry, period 4, it just kind of happened. So I'll do number 13. Oops. Okay, so it says evaluate the expressions with rational exponents. Fill in the missing values of the table based on the growth that is described. So they tell us, oh, my bad. They wrote in 2 and 6. 2 and 6. Okay. They gave that to us. So it says the growth triples each year. So every year, this bacteria growth triples. Okay, that makes sense. So from 0 years from the start to 1 year, it should triple. 2 times 3 is in fact 6. So that checks out. Let's fill in the other whole years of our table. I don't know, it would make me feel better. Okay, so every year it triples. So it goes from 6, year 1, so year 2 it should triple, 18. Oh, I guess that's all we can fill in. All right, well now, back to what we were doing in class. you need to fill in these missing values. Okay. All right. So we're going to be multiplying by the same number each time. So we start at 2, and then we're multiplying by some number. Let's call it R. Okay, we're multiplying by some number R. You can pick any letter, doesn't matter. This is just for you to do the problem. Okay. So we know 2, 6, and 18. So we can either use 6 or 18. 6 is closer, so I'm going to use 6. All right. How many times are we multiplying by R to get to 6? 1, 2, 3. I multiply by R to get here, and then again and again, so 3 times. Okay? So it's how many spaces, or it's how many times I'm multiplying by R before I get to 6. So 1, 2, 3. Okay. Now we're just going to solve this equation. Where's my, there it is. So your first step, you want to get R cubed by itself. So you're going to divide by 2. Okay, that cancels out this 2. 2 divided by 2 is 1, which is just R, R cubed. 6 divided by 2 is 3. Okay, but you're not done. R cubed is 3, but we want to figure out what regular R is. That sounds weird. Okay. So, whatever this number is, you're going to take that root of both sides. You're going to take that root of both sides. So I'm going to take, I'll write down here. I'm going to take the cubed root of R cubed. And I'm going to take the cubed root of 3. Okay? So, don't panic. Oh, cubed root, sorry. There should be a little 3 right there. Cubed root of R cubed. These cancel each other out. I'll come over here, so you're just left with R equals, leave it like this. You could make it, these 3's do not cancel. That's just a coincidence, okay? It would have to be 3 cubed for them to cancel each other out, okay? They don't cancel each other out. So you could turn it into a decimal, but like I said before in class, I wouldn't. So just leave it as the cubed root of 3. So that's what you're multiplying by each time. Okay, to make this more real for you, I am going to turn it into a decimal. Hold on. Let's do the cubed. Okay, so the cubed root of 3, just to make it, this is a number, okay? We're just leaving it in this form. But really this is, I had it as it 1.4422 ... Okay, so it is a real number. We're just leaving it in this form because this is messy. All right? And it also makes it easier to see what we're doing as we go through the table. Okay. Anyways, so I'm going to go ahead and get rid of this. That's our r. So that's what we're multiplying by each time. So from the 0th term to this term, I'm multiplying by the cubed root of 3. I need more space. So that's going to be 2 times the cubed root of 3. That's all you write there. 2 times the cubed root of 3. Hold on, I didn't make more room up here. Oh, bummer. One third, 2/3, 1. Got what I was doing? Oh. 4/3, 5/3. And this is 2. 7/3 and 8/3. Okay. Oh, you can still mostly. I didn't think I was going to have room, but I do. Let's move that way. Okay. Anyway, sorry about that. So now you're going to multiply by r again. Oh my goodness. I'm making a mess this morning. So then you would have 2 times the cubed root of 3 times the cubed root of 3. Okay. The cubed root of 3 times the cubed root of 3 is just 2. Let's say actually, let me see how they write it in your book. Hold on. Okay, they do just leave it like that. It's 2 cubed root of 3 squared. Okay? These are different numbers, so they don't cancel out. So you just have to leave your answer like this. Okay? If this was a 2, then they would cancel out and you would just be left with a 3. Like, okay. If this was a 2, or actually, if it's a 2, you don't write anything there. But if there was a 2 here, those would cancel out. But it's not, it's a 3. So these don't cancel each other out. Right? So you can just leave it like this. So this next one is 2 squared. Okay? And look, we can even look. From here to here, all I'm doing is multiplying by an extra cubed root of 3. All right? The next one. Okay. So now I have 2 times cube root of 3 times cube root of 3. And then I have to do it again. Multiply by r again. Cube root of 3. Oh no, they did get it right. Okay, sorry. I thought the book got a different answer than I was about to get, but we're good. So this is really the cube root of 3, 1, 2, 3, cubed. Okay. I'm multiplying it by itself 3 times. That's why I get the 3. Okay. Now your 3's do cancel out. And you're just left with 2 times 3, which is in fact 6. Which they gave to us and I just erased it. Sorry, there's a 6 here. They gave it to you in the book. My bad. Okay, so that checks out. We got the right answer. All right, so then you just carry on. So now you have Actually, I'm going to leave that out there. So this was 2 cubed root of 3 times the cubed root of 3. So that was there, and then there, times the cubed root of 3. And that is what gave us 6. And now here we are, so we have to multiply it by it again. Oh. Cube root of 3. Okay, but we'll come back to this in a second. I'm just multiplying by it every time. So now this one's going to be 6 times the cubed root of 3. Okay? Once again, you could multiply this out and you would get a decimal. But you don't, yeah, I wouldn't. Leave it like this. All right? You should see a pattern here. And now we're going to multiply by this cubed root of 3 again. So that'll give us 6 times the cubed root of 3. And this is squared. Just like here, except now there's, 6 times the cubed root of 3 squared. Okay. And then for 2, let me catch up on this guy. Cube root of 3, cube root of 3. Okay, so for this guy, I forgot what I was going to say. Wait, okay, so this is there, to there, to there, to there, to there, okay. 3, 4, 5. Now I forgot what I was going to show you with that. Maybe it'll come back to me later. Okay, well, let's figure out 2. So we have 6 times the cube root of 3 squared, which is cube root of 3 times the cube root of 3. And now we have to multiply it by it again. All right, once again, this is actually 6 cube root of 3 cubed. Okay, so once again, your 3's are going to cancel. And so you have 6 times 3, which is 18. Which we also already filled out. I can't keep track. All right, well, that checks out. So we know that's right. Okay, and then this one would be 18. You multiply by r again, so 18 times the cubed root of 3. And then you would have 18 times the cubed root of 3 squared. Oop, I need to move you this way a little bit. Hold on. Woo! Did it. Okay. Whew, that was a lot. Okay, I posted exponent rules on Canvas because 15 through 20, you need to know your exponent rules. Let's just look at 15 real quick, and then I'll show you the actual rules. So 15. Three squared times 3 to the 5th power. 3 squared times 3 to the 5th. So, exponent rules. If you have the same base, you just add your exponents together. So keep the same base, and then add your exponents. 2 plus 5 is 7. Okay, and they just want you to leave it like that. Okay, So once again, I posted them on Canvas, but here we go. So if you're multiplying, I don't know, what letter should we use? We'll do B. So you have B to the X times, hold on. Okay, we're good. So B to the X times B to the Y would be, they have to have the same base, which they do. The base is B. So you add the exponents together. So this would be X plus Y, okay? So that's the example like we just did. So that's if you're multiplying them. If you're dividing them, B to the X over B to the Y. Oh, come back this way. There. Then you subtract, same base, you subtract your exponent. So it's B to the X minus Y. An example of that, I'll just use 4. 4 to the 5th over 4 squared. Okay, they have the same base. The base is both 4. So you subtract your exponents. 5 minus 2 is 3. And that would be your answer there. Let's do B raised to the 0 power. Any number raised to the 0 power is 1. So that could be like 5 to the 0 power is just 1. Any number raised to the 0 power is 1. I'll do that. What else do we have? Okay, we have AB to the X power. Okay. Hold on. This is called, oh, there it is. The power of a product rule. So this is equal to, hold on, I keep shutting my screen. There we go. Ugh. Okay, so this is equal to A to the X times B to the X. So it goes to both of them. Okay? So an example, 5. We're trying to think what would make more sense. 5, we'll do 5x raised to the second power. I don't know. Okay? So then it has to go to both of them. So that would be 5 squared times x squared, which would be 25x squared. Okay, so it goes to both of them. Okay? All right, we'll go over here. And then you have, you have a negative exponent. Like if you have b to the negative x, that means it wants you to write the reciprocal. So it's 1 over b to the x. So it turns it into a fraction. Okay, an example with real numbers. 5 to the negative third power. Okay, so that means it would be 1 over 5 to the third. All right? And then I'm trying to think. Okay, and then I think you need, I don't know if you need this one. We'll just do it. So it is, if you have b to the x raised to the y, okay, so in parentheses, b to the x raised to the y power, that turns into b to the x times y. All right, so then you multiply your exponents together. Real number example of that, let's say you have 2 to the third, and all of that is raised to the fourth. So you would multiply your exponents. So that would be 2, 3 times 4 is 12. So really that's 2 to the 12th power. Okay. Oops, wrong thing. Keep doing it. There you go. Okay, so those are some examples, but I posted them all on Canvas.